In this video, we'll look at applying the rules of differentiation to find stationary points. So let's first of all have a look at the graph software. So I've got here a curve and I've put on a point on the curve and we've got the tangent drawn, this dotted line, and I've got here the gradient of the point. So we're going to see how the gradient changes as we move round the curve. So at the moment it's a positive gradient. So as we go around, gradient still positive, but it's getting smaller and smaller. And then as we get to the top, we get to a point where it's actually a gradient of 0. It's actually a horizontal line, and that's right at the top of that curve there. And then as we go past that point, we've now got a negative gradient. So our gradient's getting more and more and more negative. And then as we get down to the bottom here, our gradient's getting less negative now. And then at that very bottom point, we've got a gradient of 0, a horizontal line. And then as we go round, we've now got a positive gradient again. So we've got around this bit here is a positive gradient. At this point here, we've got a negative gradient. And then here, at this point here, we've got a 0 gradient. Here we've got a negative gradient. Here we had a 0 gradient. And here we've got a positive gradient, and I'll just put in here is also a positive gradient. So we've seen two positions where we've got a gradient which is 0, or the tangent is a horizontal line. So down at the bottom and there up at the top. Now let's have a look at another kind of graph and see if there's another type of point where we've got a gradient which is a horizontal line. So I've got this curve here and I've done the same thing. I've got the tangent line drawn in blue and my curve is drawn in red. So if I move around my curve, at the moment I've got a positive gradient. So let's sort of move forwards. That's our positive gradient, but it's getting flatter and flatter, and then I get to a point where I've got a flatter and flatter and flatter gradient, and it actually becomes a 0 gradient. And if we look at the gradient over here, it's not quite 0, but if we move forward, it's a little bit closer to 0. That's more or less 0. And then it starts getting more positive again. So we've actually never found a negative gradient. It's always been a positive gradient. But at this point, approximately here, we've actually got a horizontal line, so a horizontal gradient. So we've now found another type of point which gives us a gradient which is 0, or a horizontal line. So let's summarize that. So we've got where dy dx is 0, so that's where our gradient is 0. We call these stationary points. So I can underline that or highlight that. So they're stationary point. We've got different types of stationary point. So we've got this type here where the gradient is 0. We've got this type here where the gradient is 0. And this type here where the gradient is 0. So these are all where dy dx is 0. And we've got different names for them. They're all called stationary points, but this one here is a local minimum point. So I'll highlight that. That's a minimum point. So here. And then we've got this one here, which is a local maximum point. I'll do that one in green. So that's a local maximum point. And then we've got this other one here, which we call a point of inflection. So it's a positive gradient before to the left-hand side, and it's a positive gradient after to the right-hand side, but it actually reaches a gradient of 0 at this flat point here. And then we've also got another bit of terminology where we've got a positive gradient. We call it an increasing function. So for example, this would be an increasing function. This would be increasing. And then where we've got a negative gradient, we call it a decreasing function. So an example of that would be this part of the curve here between the maximum and the minimum. So need to go a bit closer to there. So those are our three types of stationary points, and they're all called stationary points. Now let's have a look at an example of a question we may get related to stationary points. So we're given that the function or the graph y equals 3x cubed minus 3x squared plus 1, and we're asked to find the gradient, so find the stationary points. So that's where dy dx is equal to 0. So we need to differentiate, so that's going to be 3 times 3, which is 9, x to the power 2, and then minus 2 times 3, which is 6, x, and the 1 just disappears, so 1 becomes 0. So we're trying to solve this equation here. So best thing to do, I think, is factorise. So I've taken out 3x, and we're left with 3x minus 2, and that would be equal to 0. So either x is 0, or, from the second bracket, x is 2 over 3. Now to find the points, so the y coordinate now, we substitute back into the original function, which is this one here, to find the y coordinate. So y will be equal to, well, substituting in 0, we've got 0 minus 0 plus 1, so y equals 1. And then the second one, when x is 2 over 3, substituting that into the y expression, we get this, and then using the calculator, we get y is equal to 5 over 9. So we've got one coordinate is 0, 1. So I'm going to just write that one down. So 0, 1. So our first coordinate, and the second coordinate is x is 2 over 3, and the y coordinate is 5 over 9. And those are our two stationary points.